So, how many people have ever experienced a swallow?
No.
Give me 3 more minutes.
Yeah.
Actually, what time do you guys need to leave? What time do you leave?
Game starts at 7.
Okay, so it's 6:48.
Yeah, we can have
Okay, I'm gonna come back to that part. I want to go real quick forward, and I'll come back to that because this is the current weather pattern that we are in right now. So I pulled this off of. It's a great web page to go to. It's called aviationweather.gov. So I have an app that makes this stuff look a little bit fancier. It's a pilot app that's actually quite expensive. It's like $400 a year, but I love it. But it takes this kind of information. So this is basically the weather pattern today. These gray lines are maps of equal pressure, so it's called the pressure, pressure lines, pressure contours. Do you think there's much wind today? No. Because these lines are like close or a long way apart. What about up here in Canada? Do you think it was pretty windy today or not too windy? Well, do you think it's windier here than it is here?
Yes.
A lot, because I mean, look how far apart these are. These are packed doubly as tight. If you've ever seen this image for a hurricane, you've got like really tight rings right around it.
How many millibars is that?
So this 1020 is in millibars. So this says this high pressure is 1,020 millibars. That's what that number means right there. This high pressure is 1,020. This low pressure is 1,014, so not much difference, right? These are not very strong low pressure systems, 1,002. Hurricanes could be 940. I think the record is 928 or something like that. Say again? Not for millibars. So millibars, you might be thinking of inches of mercury. So standard pressure inches of mercury is 29.98, which is 1,012 millibars, I think, 1,012. So this says 000 UTC Tuesday. What time is that? Midnight? UTC, where's that? Right, so what time is this map for here? Are we ahead or behind UTC? How many hours? 5. It's the summertime. 4. Wintertime we're 5 behind, summertime we're 4 behind. 5 in the winter, 4 in the summer. So 000 UTC is 2400, so it's 8 o'clock here. So this is the projected map. So you can see this front has started to move closer to us. Right? Now you can see if you go forward, another one, this is 0600, these are 6-hour forecasts. You can see this front start to track. This green like this means there's a slight chance of rain. This means a stronger chance of rain. So there's a chance of rain tomorrow. Getting better as you go later in the morning. And then tomorrow night there's a fairly good chance. All right. See you guys. You can sail on today. So this is kind of when the front is almost at us at 8 o'clock tomorrow night. So for the guys doing Larchmont Race Week, I think there'll be a full day of sailing tomorrow. And I think, as you can see, as this front has moved closer, what's happened to this pressure contours?
It's increasing, sir.
All right, so what's it going to be tomorrow? Windy?
It's going to be so windy tomorrow.
It's going to be very windy. It's not going to be very windy tomorrow, but it's going to be windy tomorrow.
When's tomorrow supposed to be so windy?
It remains to be seen. I think tomorrow's going to...
Will the front just move through by Wednesday?
By Wednesday it will move through. Sometime overnight Wednesday it's going to move through. So I think tomorrow is going to be 12 to 14 with gusts to 16 or 18. Now the question is, what's it going to be Wednesday morning? Because Wednesday morning, on the back side of this, now look how tight those two lines are together. Now by the way, which direction, so this is tomorrow at 8 o'clock, which direction is the breeze going to be? So you can see they've represented there's a little low pressure system that's developed in the center of it. Which direction is the breeze going to be here tomorrow?
West?
Yeah, kind of southwest. Right? Depends on how much influence that low has to bring it around, but it basically typically the breeze wants to go in between isobars. So wherever you see these isobars, which are what these pressure contours are called, wherever you see isobar lines, typically you'll see the wind going in between it, depending on how it's influenced by a high or low. So this is a high pressure system, so it'll be very light wind going this way because the wind is blowing out from the high, and therefore it'll curve to the right. And the low pressure system is moving in and gets tighter, again, curving to the right. And then at some point the front will pass, and what direction will the wind be on the back of the front? Yeah, so Wednesday morning, what direction breeze, Maddie, do you think you'll be sailing in?
Oh God. Westerly.
Low pressure's here. Breeze typically goes in the lines of the isobars. So it'll be north-northeast. Yeah, it'll be north-northeast is the breeze that you'll probably be sailing on Wednesday.
So tomorrow's full day. Tomorrow's full day.
I haven't looked at and obviously these things change, because the speed of the movement of these things changes. But I looked at this a couple hours before I came here, is when I pulled this, and I looked at it again. And it's been pretty much on time that it's going to go, the front's going to go through sometime around midnight, plus or minus a couple of hours, which means I think you'll probably have a full day of race. Now the question, will there be any convective activity, which is thunderstorms, out ahead of this? So this says there's a chance, right? So will there be thunderstorms that would make the race committee say, okay, we need to close this early because there's a chance of thunderstorms popping up? Make sense? Okay. So let me go back and talk about, so we talked about the squall line. So let me go forward one more time. So you can get squall lines at night, but a lot of times you don't. But where would you get the squall? I mean, I just showed you, right? Where would you get the squall line along this front? It would be here. So when this front goes basically right over us, the squall lines happen, and you guys have been here for a cold front. Like a cold front goes through, it's blowing the dog off the chain, it's raining, it's storming, and then the cold front passes, and all of a sudden the sky turns blue. In like a matter of an hour, it gets beautiful behind it. You know, with a nice, cool, low humidity breeze. So that's where the squall line would come through. The thing you guys need to and there are quite a few questions on lightning, which is why I put this in here, about what you should do in the case of lightning, because squall lines, cold fronts typically are the ones that will have squall lines associated with them, or anytime that you get just an individual cell, thunderstorm cell. So what creates the thunderstorm cell is hot air, right? It's really hot, like, so you've heard of pop-up thunderstorms? The air is hot and humid, right? Which means that when it's humid, there's a lot of moisture in it, which means it's unstable. And so that air heats. As it rapidly goes up through the atmosphere, is the upper atmosphere cooler or warmer than down here? Cooler to a point. Eventually it gets really hot, right? But so when you're, if this is the atmosphere and this is the earth, right? For the first long way. It's measured in miles. Let's say 30 to 40 miles. For the first 30 to 40 miles, as you go up, for every 1,000 feet you go up, the temperature goes down about 3 degrees Fahrenheit. That's why it's cooler in the mountains. So if you were at a mountain that was at 10,000 feet, how much cooler would it be at 10,000 feet?
30 degrees.
30 degrees cooler. If you're at the top of Everest, which is almost 30,000 feet, how much cooler is it at Everest?
90,000.
90 degrees cooler, right? But that's why in the summertime, right? People are going to Everest in the summertime, and what are they wearing for clothes?
Jackets.
I mean, they're wearing full-on down suits that are rated to minus 200. Okay? So up to about 30 or 40 miles, it's basically every 1,000 feet you go up, you get 3 degrees of temperature drop. At this point then, the temperature starts going up, and because you're now into the ionosphere, which is out basically right next to space, and that's capturing all the radiation from the sun. And this is what, like when a spaceship, like a space shuttle comes through, why it burns hot. And so this range up here, I think it gets up to like 20,000 degrees Fahrenheit. So we're gonna die. You don't want to be there. You would die. So let's say, anybody know about how high a thunderstorm top is? Any guesses?
30,000?
It's got to get to about 30 to 35 before you get anything interesting. Probably 40 to 55, you're going to get some really, really good storms. The stuff you get out in the Midwest, where they get the big tornadoes, some of those get up to 65, 75, even 85,000 feet. Okay? Storms around here, you know, rarely do we see a storm get up much above 60,000 feet here in its cloud tops. But let's say it's 60,000 feet. So if it's 60,000 feet and you're dropping 3 degrees, how many degrees have you dropped in 60,000 feet? A lot. Right? A lot. You know, 180 degrees.
Not how hell works.
That's exactly how hail works.
Freezes, goes back down.
That's exactly right. So you get a day like today where, I mean, we're all sweating, right? I mean, you can feel how much moisture there is in the air. Imagine you take this air mass that we're in and all of a sudden you launch it at a fairly rapid rate up to something that's 180 degrees cooler. What's going to happen? It's going to freeze, right? And that's what creates hail. That's what creates thunderstorms. Is these things go up and they go up and they go up. It cools off, the air, colder air can't hold the temperature or can't hold the moisture anymore. That's what creates rain.
So what, is it the cold front that like wedges the hot air up, or like, yes, this is a cold front that brings hot air up?
Exactly.
Why would hail is more likely to happen in the West? Because species are higher up.
It happens because, how do I explain this without getting too technical? So what's interesting in the Midwest is that the atmosphere is overall much drier. So when you get storms that happen out there, the moisture differential between down low and up high is greater.
They're less like 15 minutes.
Yeah, but there's some storms. I mean, there's tornadoes that have been on record for going for like an hour. You know? And so there's a lot of unique things about our atmosphere here where we are that wouldn't allow big storms or storms as big as the Midwest to develop. Okay? So when you have this energy that goes up, not only do you have hail, you also create, you got all these molecules rubbing together, which creates what?
Lightning.
Right? Creates energy, which creates lightning, creates static electricity. So if you've ever rubbed your hands, have you ever like rubbed a balloon against your head? You know, so it's static electricity. Exact same concept with light, right? Is you've got all these molecules in the atmosphere where it's unstable, just moving around. It's like somebody's got a bunch of big ass balloons, you know, moving around, creating all this static electricity. And at some point in time, that static electricity, who's ever shuffled on a carpet and gotten shocked when they touched something? You can shuffle on the carpet and you don't get shocked, right? When do you get shocked? When you get close, like a light switch or a doorknob or something like that. Now, do you even actually have to touch it?
It's definitely near.
It's got to get near it.
Jumps through.
Jumps through. Why does it do that? No. It's seeking to go to ground. So there's a concept in physics that basically says things want to be in a state of stability. Things want to be stable. And therefore, if you've got something that's energized, it by nature is seeking to be stable, and it's looking for something. So the most stable thing that exists in electricity is what's called ground. Literally, physically, the earth that's around us. So if you have static electricity and you get close to ground, the static electricity will jump from your finger to there, and that's what creates the shock. Same thing in lightning. A bunch of balloons being rubbed up in the atmosphere because all this stuff is going up and down. It wants to seek stability, and so at some point in time, there's so much energy, it says, where's ground? And it jumps to ground and discharges all the energy. Does lightning usually hit higher up or lower down?
Higher up.
Right, because all the energy's up here in the atmosphere, and so it's going to get to the thing that's closest to it. On a sailboat, what would that typically be? A mast. Exactly. So here are some guidelines. So does that make sense? Is that helpful to understand storms and lightning? So, lightning guidelines. So the first thing you want to do is you want to make sure you're on a boat that meets what's called RYC, which is the American Boat Yacht Council guidelines for lightning protection. you can rest assured that Strange Brew and First Light both fall into that category. Look, if possible, stay ashore when lightning's forecast. Right? That is a good strategy. However, as offshore sailors, we can't do that, so we have to be able to deal with it. If possible, head ashore if time and conditions permit. However, I think it's never a good idea to try and outrun a storm. Because if you've identified a squall line that's coming, it depends on how you've identified it. If you've identified it because you've looked at a forecast and you say that a squall line is going to come through at 7:20 tonight, right, and therefore I want to be back at the dock at 6:30, that's fine. If you look down the sound and you say, oh crap, look at that, and you pull up your weather radar on your phone and you're like, oh, I didn't see that squall line coming. You know, these things move 30, 40, 50 miles an hour. I believe, instead of trying to make it to shore, where bad things are going to happen in a really, really strong breeze in a chaotic situation, a lot of times it's better to be out just a little bit, right? It's better to be out in Great Captain Harbor and let it go through. So that's my next point. Don't try to outrun a squall unless you're 100% sure. So if you have an imminent offshore encounter, shorten sail well ahead of the lightning or high wind. So if you're in the Stratford Shoal race and you're halfway down to Stratford Shoal and you know there's a squall line coming through, what should you do? You should take the spinnaker down and you should probably put a reef in the main before it starts blowing 40. Because it's going to blow 40 or 50 for a short period of time. Okay? You want to get as many people in the cabin as possible, however, avoid the mast and the chain plates. So you don't want people sitting next to the mast, and you don't want people sitting underneath the chain plates. Anyone know what the chain plates are? Where the shrouds come down and attach to the deck? That's the chain plates. Okay. So you don't want to be there. You want to avoid the area around the keel, because the keel is where the ground wire from the top of the mast, that's made of copper, which is a very conductive metal, is attached to. So if you've ever taken apart a big sailboat or been involved in it, you'll see there's a big, it's usually actually kind of a greenish color because it has a paint on it to increase its conductivity. But it's a copper wire it's probably about that big around. You know, it's bigger around than my thumb, or the size of my thumb, that goes from the top of the mast down through the center of the mast and attaches to the keel, and actually then is buried in the lead of the keel. Thinking being that the lightning will strike that and go through the boat and not impact anyone. You also want to avoid being any place that is a non-grounded metal. So like winches. Winches aren't grounded. The steering wheel typically is not grounded. You don't want to be over a sea cock. Any place that there's metal, significant metal that's touching quote unquote ground, which means the sea, is a likely place for lightning to seek out and exit. So you probably don't want to be in the head because there's probably a sea cock in the head. You know, but you can avoid it. You want to avoid the cockpit if you can, because the highest concentration on a boat of non-grounded metal is in the cockpit. However, if you do have to be in a cockpit, stay low and stay out of arm's reach of anything metal. Yep.
What's this seacock?
Say again?
What's this seacock?
A seacock is where anything that has water goes overboard into the sea. So for example, the raw water strainer for an engine is a seacock. So typically what a seacock is, it's just like there's no ropes on a boat. Yeah. There's no valves on a boat. So typically a seacock is a 90-degree piece of metal that has a handle on top of it, right? And so, like if this is the engine over here, how do diesel engines cool? Air. Water. They draw raw water in. They have something called an impeller, which is basically a rubber vane-like propeller that spins around at the speed of the engine, which creates a suction and pulls raw water in. There's a strainer here so it doesn't get seaweed in. And then there's actually typically a strainer inside, so the water comes in here. So it pulls it in through this seacock and in through this strainer and then into the engine, circulates it through a heat exchanger that takes the heat from the engine and displaces it to that cold water and pumps it back out the exhaust pipe. So then if this is the stern of the boat, there's an exhaust pipe here. Right? And whenever you start a diesel engine, the first thing you want to do is make sure that there's water trickling out. Because if there's not water trickling out, you might have a problem with your raw water system and the engine's going to overheat. On an outboard motor, it's got the little This is an outboard motor, right? You know, prop here. It's got a little stream of water that comes out the back of it. Same thing, there's an impeller and there's a screen on this very bottom of the lower unit that brings in seawater, pumps it up, exchanges the heat. And so if you ever go put your hand, I wouldn't do it if the engine's been running really hot, but after you start it, put your hand behind that and feel that water heat up as the engine idles, because it'll get hot. So that's what a seacock is. Make sense?
Yeah.
So seacocks usually for engines, there's seacocks for air conditioners, there's seacocks for generators, there could be seacocks for overboard tanks. So if you have a tank that can pump overboard, could be seacocks for sinks.
So is seacock is also like those air scoops? Is that a seacock? Like kind
No, a seacock's not an air scoop, but it could, an air scoop where it's metal.
Yeah, like a brass.
Yeah, that could be someplace in lightning with seacock for sure. Make sense? Remember, likelihood of offshore lightning strike is low. A properly protected boat should give you a cone of about 45 degrees from the top of the mast. So if this is a sailboat, all right, if this is a sailboat and this is your mast up here, if you're in this range, basically, in theory, from a lightning strike, you should be safe. So, this is not a picture of the boat that I was on, but this happened to me in the 1990, probably 90 or 91 Put-in Bay race, which is about a 75 nautical mile race from Cleveland, Ohio, around an island that's about 35 miles off to the east up by Erie. And I was sailing on a Freres 55, a boat called Legend, which I raced on for a long time. A very, very successful boat in the Great Lakes. We were about an hour and a half after the start. Pop-up thunderstorms around. I was trimming the spinnaker, and we were on Port Jive, and I mean, it's a good-sized boat. I typically would stand in between the shrouds, like, because the stern's to it. I'd stand in between the shrouds, so I could kind of lean back on the shroud as I trim the spinnaker, right? Ease it, trim it in, tell the guy to ground you or whatever. For some reason, I mean, that it was starting to get a little, I mean, you could tell that it was getting a little squirrely, right? And we were actually talking about where we were going to shorten sail, where we were going to peel to a different kite, and the storm kind of came up out of nowhere, and it started blowing fairly significantly in a very short period of time. So I headed back to the cockpit, and we were just getting ready to peel to 1.5 ounces. So it was back in the old days that weren't asymmetricals, everything was symmetrical kites. And all of a sudden I heard the loudest boom, and I look up, the spinnaker's basically gone, and the main is flaking down. It's flaking itself down. And I'm like, what the hell just happened? Right? And I didn't know, I mean, it was just, just a boom and a flash. And the skipper goes, oh, we just got hit by lightning. So needless to say, we withdrew. So they pulled the boat the next day, and this is almost exactly what the boat looked like directly underneath the chain plates. So that lightning strike went down the port shrouds, right out the bottom of the boat, and it blew 3 or 4 holes in the bottom of the boat. And on ours, there was a part that was about that big around that all the bottom paint had been blown off of. Our bottom paint was blue, and there was a section that big that just looked like, kind of like chipped gel coat. Nobody got hurt. Yeah.
So that thing, are you safe inside the 45 or outside?
In theory, you're safe inside the 45. In theory. So first-hand experience, I was on a boat that got struck by lightning, direct hit. I'm here to tell. All right, look. Yes, okay.
Oh, sorry, so it's 45, so not like 90.
It's
There's just not discovered.
if you were looking down at the top of the mast, imagine a cone.
Oh.
So you're looking out the side of the mast, where basically this is 45 and this is 45. So it's 90
Any
degrees.
direction, 45? So from any direction?
Any direction, 45. Yeah. In
So
theory.
it's like 45 from the top of the mast, so like 22.
No. It's like 4. And again, that's just kind of like a rule of thumb. It's not that lightning can do anything. But the theory is, if you've got a properly grounded boat, it's going to realize that there's something that's ground way up here. It's going to strike that and then pass through whatever that is, down the shroud or out the keel into the water. Okay. Let's take a short break. and we'll come back and wrap this section up.
We're gonna need the maps today.
Sorry.